Hello everyone, welcome to Praveen Online Academy. Today we are going to discuss the chapter Matter Around Us. In this chapter we are going to discuss the properties of solid, liquid and gases in this chapter. So matter around us. First, what is meant by matter? What is meant by matter? Matter, anything that has mass and occupies space. Anything that has the mass and occupying space is known as matter. From the small, minute, invisible particle to the larger particles considered as a matter. So matter can classified into majorly classified into three categories, that is solid, liquid and gases. From the chapter we are going to discuss the properties of solid, liquid and gases. Properties of solid, liquid and gases. States of matter. So states of matter are classified into three categories, that is solid, liquid and gases. Look at this activity 1. Identifying the shape and volume of the liquids. For doing this activity we need the measuring jar that is cylindrical, contains of different shapes. So we have to take the different types of jars, containers, which is having the flask, conical flask, test tube, beaker and glass jar. While you are taking different types of jars, containers, try to pour the liquid, the water in the different types of jars, containers. We can observe that the shape of the liquid depends upon the jar. For example, I am pouring the 100 ml of water. Look here the 100 ml of water that I poured in the beaker and 100 ml of water that I poured in the flask and 100 ml of water that I poured in the conical flask, test tube, beaker as well as glass jar. From above these 6 containers I poured the same type of liquid, but the shape of the liquid depends upon the container. From this we can say that the shape of the liquid depends upon the container. Liquid doesn't have proper definite fixed shape. Simply the shape of the liquid depends upon the container. From the test tube, when we pour the water, we can say that the shape of the liquid is in a cylindrical. Clear? From this activity, we can say that the shape of the liquid will depends upon the container. So from this, we can say that liquid doesn't have proper shape. Shape. So this experiment is saying that you can pour the water in different types of containers and observe the shape of the liquid in different containers. From the above activity we can say that the shape of the liquid varies from the container to container. From the above activity we can say that liquid doesn't have fixed shape. The shape of the liquid depends upon the container. Next, coming to this activity 2. Activity 2. Do the gases have definite shape and fixed volume? Coming to the gases will have definite shape and fixed volume. Let us find out this and with the help of this experiment. Look here, everyone know this. I think everyone seen in your daily life activities. This is a CNG car. The yellow cylindrical tube-like structure is known as CNG gas filled. What is the full form of CNG? Compressed natural gas. The use of CNG, majorly we use the CNG in automobiles. Compressed natural gas is known as CNG. The full form of CNG is compressed natural gas, also shown. So majorly we are able to see in this CNG in automobiles, running vehicles, 4-wheelers, 6-wheelers, 2-wheelers. So does the CNG has a fixed volume? Does the CNG has a fixed shape? CNG is a gas. CNG doesn't have fixed shape and fixed volume. From the gases we can say that from gases doesn't have fixed shape and fixed volume. The shape and volume depends upon the container. The shape and volume depends upon the container. So this is the image of the CNG. Observing the compressibility of different materials. Compressibility. First, you can take the example as duster. When you take the duster, that is sponge duster, which is in the form of sponge, take the dusters and try to press on both either side of the duster. After pressing, you are able to see that the duster is able to forming into smaller size, smaller size. After releasing your hand, the duster is able to retain their original shape. The duster is able to forming the smallest shape due to the intramolecular spaces due to the compressibility where the intramolecular spaces between the duster is higher. The intramolecular spaces were higher. Due to the intermolecular spaces, the compressibility will depend. If there is more if the intermolecular spaces are very loosely packed, the compressibility will highly. Coming to activity 3, observing the compressibility of different materials. Before doing this activity, first take the duster which is made up of sponge. Take the sponge duster, imagine it's a duster. Try to press the duster on the both sides. When you're pressing with your hand, the duster is able to form into smaller size, right? The duster is able to form into smaller size. But when you're releasing your hands, the duster is able to retain their original position. The duster is able to form into smaller size because the compressibility, the intramolecular spaces between the duster is loosely packed. The intramolecular spaces are loosely packed. Due to the presence of intermolecular spaces, the compressibility will depends. For example, the intermolecular spaces are very loosely packed, there is highly compressibility. If the intermolecular spaces of an object is tightly packed, the compressibility is negligible or very little. Depends upon the intermolecular spaces, the compressibility will depend. Simply, the compressibility is the intermolecular spaces are very tightly packed, the compressibility is negligible or very little. If the intermolecular spaces are packed very freely, intermolecular spaces are and freely, the compressibility will be higher in nature. He given an experiment with a syringe, and what he given, take a 50 ml of syringe, draw the piston to stuck in the air, place your finger on the nozzle and press. Observe the depth of the piston moved into syringe. Is it easy or hard to press? So take the syringe, and everyone know the syringe, right? It is a syringe. So this we call as a nozzle and it we call as a piston. Take the syringe without having a needle. So try to draw the air from the atmosphere with the help of the piston. After drawing air, just close the nozzle with the help of your finger. Close the nozzle of the syringe as shown in the figure, and try to push the piston to inside of the syringe. Try to push the piston to inside of the syringe. While you're pushing, you're able to observe that. The piston is able to moving hardly. The piston will start moving freely. While the piston is able to moving inside, you are able to feel that the piston is able to moving very hardly. That is due to, from this experiment we can say that, so it is a syringe and it is a piston. So before dragging air inside the piston, when you are dragging the piston, the air enters into the piston, air particles enter into the piston. So while you are before doing this experiment, you are closing this nozzle with help of your fingers. Simply it will prevent the escaping of the air particles, air present inside the piston. While you are pressing your piston, so the piston starts moving freely. After entering some distance, the piston starts move to very hardly forcibly. That is due to the intramolecular spaces very tightly packed. Due to the tightly packed, the compressibility will be negligible. From this experiment we can say this, the compressibility. And he given some question, what do you find any change in the volume in the air of the syringe? Now fill the water in the syringe and press the piston. You can do this experiment with help of the water and the solid particles like sand, pieces of sand. Try to do that with help of 3 different types of, that is gas, that is atmospheric gases, and solid, like take the sand particles or wooden block, and liquid coming to, you can take any water or milk, that whatever you want. From this above experiment we can say that we taken the 3 substances like solid, liquid and gas. We taken the 3 activities, that is solid, liquid and gas. From these 3 experiments we can find that The compressibility in gas is more, the compressibility in liquid is very low or little, the compressibility in solid is negligible or very low, negligible or very low. From this activity we can say that compressibility of gas is more and liquid is moderate or very less and solid is negligible. And these are the CNG gases. And before that you have to know about LPG gas, liquefied petroleum gas. Liquefied petroleum gas, that liquefied petroleum gas majorly used for cooking purposes. Whatever the cylinder that present in your kitchen, that liquid is made up of LPG, that we call as LPG cylinder. Majorly LPG cylinder used for the cooking purposes. The full form of LPG is liquefied petroleum gas. Next he given that, before that he given that think and discuss. Let us stretch a rubber band. Is there change in the shape? So take the rubber band, try to stretch the rubber band. Is there any change before and after stretching? Yes, there is a change. After stretching, the rubber band is able to exchange the distance, right? And after releasing, the rubber band able to coming to retain their original position. And what is given? What will happen if the stretching stop? What will happen if the stretching is too much? If you stretch elongate the rubber band too much, it is able to breakage. And what happens if the stretching stops? If you stop the stretching, the rubber band is able to coming to their original position. And this rubber band is in the form of solid state. The rubber band is in the form of solid state. Next, what is given? Can you compress it? It is a solid. Why? Think and discuss. Before that, you given that question, which takes some finely powdered salt. So you have to take the salt which is in the form of powder, not in the crystal shape, and keep it in two different jars. After keeping in two different jars, what do you have to say? Which shape does the powdered salt take? Can you say the salt is a liquid on the basis of the change its shape? Justify your answers. While you're keeping the powder in a jar, the shape of the powder will depends upon the jar container. Clear? The shape of the powder of that solid, whatever the solid we are taking, that depends upon the container. Next, activity 4 regarding, given the activity 4. That activity is 4 regarding observing the diffusion of gases. So in this activity, take the incense stick, let your friend to hold the incense stick and let him to stand at any corner of your room with the unlit the incense stick. So you can find that there is no smell coming from the incense stick. After same that after that you can say to your friend that let the incense stick lit. After lighting, let him to stand at any corner of your room. After some time you are able to see that the smell of a incense stick. If your friend is standing in that corner, you are at this corner, you are able to smell the incense stick. How the smell is able to traveling from that corner to this corner? Due to the diffusion. Whenever the incense stick releases the smoke, whenever incense stick lit, after lighting the incense stick start releasing the smoke, the smoke particles will mix in the atmospheric gases. That atmospheric gases will take the perfume to enter room. By this process we can say that the diffusion of gases will travel through the atmosphere. Whatever the gases that will mix in the atmospheric gases and travel along with the atmospheric gases. By that the whole room is able to diffuse with the perfume of with the smell of the incense stick. That is about regarding the activity 4, and activity 5 regarding observe the diffusion in liquids. Activity 4 regarding the diffusion in gases, and activity 5 regarding the diffusion in liquids. What you can take 250 ml of. Take 250. Activity 4, take 250 ml of round bottom flask with 2/3 of water, with filling of 2/3 of water. In it, use a dropper and put a few drops of blue or red ink, or you can take the blue or red ink, or you can take the potassium permanganate solution, KMnO4 solution, and slowly along the side of the flask. So take the conical flask, fill with the 2/3 of the water. This is the water area. It is water filled with the water, and with help of the dropper, try to give drop by drop to the liquid solution, bottom of the solution, and observe the solution absorb the liquid after adding the drop by drop of blue or red ink or potassium permanganate. After some time we can see that the process of diffusion will take place. Whatever the color is able to spreading all over the water molecules, water of the liquid. See, after some time the whole water, the color of the water changes into pink due to the diffusion. So by this experiment we can say that the diffusion can take place in liquid also. From the instance take we can say that the diffusion takes place in gases, as well as from this experiment diffusion of potassium permanganate in water, we can say that the diffusion will take place in water also. Next, we go given activity 6, observing the diffusion of particles in solids into liquids. Diffusion of particles of solid into liquids. So what are the material required? Take a beaker full of water and add few crystals of potassium permanganate and observe the changes. Repeat the experiment with the crystals of copper sulfate. Do you observe the diffusion? Is it faster or slower than the observed in the activity 4 or 5? From the above activity, you can do that process of diffusion with help of the potassium permanganate and crystal particles of the copper sulfate, and observe the diffusion, the process of diffusion taking place, and the time taken during the difference between the potassium permanganate and copper sulfate, which is in the form of crystals. Next, what is given? Given whatever substance that is occurring in our body. The substance, like what is given? During the respiration, oxygen diffuses into lungs. During respiration, oxygen diffuses from lungs into the blood. Carbon dioxide diffuses from blood into lungs. Solid, liquid and gases diffuse into liquids, and the rate of diffusion of gases is higher than the rate of diffusion that of the solids. So whatever the process of in our body, the process of breathing and carbon dioxide and oxygen exchange takes place at our lungs, that is happens due to the diffusion from higher grade concentration to lower grade concentration, and transportation of the blood, everything that happens through the process of diffusion. Here is saying that the process of diffusion of gases, the process of diffusion in gases is higher than the compared to the liquids. Simply, the process of diffusion in gases is higher, much higher compared to the liquids. Diffusion is higher and the diffusion in liquid is moderate. Next, look at this lab activity. Lab activity given that observe the speed of diffusion of two gases. So diffusion also depends upon the gases. We seen that the diffusion is higher in gases, next followed by the liquid and solid. The diffusion of solid is lower, the diffusion of gases the diffusion of liquid is moderate, and the diffusion of gases is higher. Gas is higher, liquid is moderate, and solid is less. So here the gases, to observe the speed of diffusion of two gases, the diffusion of the gases will depends upon the material substance. What is the metal liquid? Take the long glass tube. The material liquid, take a long glass tube with scale. So take the long glass tube which is having 1 meter, which is having measuring scale on it, which is transparent glass tube. Next, liquid ammonia, hydrochloric acid, pieces of cotton, 2 rubber cocks and pair of tongs. You have to take the cylindrical tube which is transparent, which is having 1 meter length, and you have to take the solution of hydrochloric acid and liquid ammonia. Then these are the rubber cocks and 2 cotton balls. The procedure is, take 2 pieces of cotton balls and soak one in hydrochloric acid solution and another in the ammonium solution. So first, before doing this experiment, take the fresh cotton balls, dip 1 cotton ball in the solution of hydrochloric acid, cotton ball in the hydrochloric acid, and 1 solution in the ammonia, liquid ammonia. So dip one cotton ball in the hydrochloric acid and another cotton ball in liquid ammonia. After dipping, what you have to do at the same time, with help of the tongs, you have to do this experiment carefully because hydrochloric acid is very highly concentrated. You have to use the safety gloves, safety kit during the experiment. So with help of the tongs, one cotton should dip in the hydrochloric acid and another should dip in the liquid ammonia. After that, place one hydrochloric cotton ball at one end of the tube and at another end you have to place the NH3 which is dipped in the cotton balls. After that, close the both ends with help of the rubber cocks. Close the both ends with help of the rubber cups and leave it for 4 to 5 minutes. After 4 to 5 minutes, this will travels, diffuses in the form of gases. Liquid ammonia and HCl will diffuses in the form of gases. After diffusion, after meeting of ammonium chloride and HCl, there is due to this chemical reaction, there is a formation of wide ring-like structure. Formed inside the glass tube. After 4 to 5 minutes, we can see that there is a formation of wide ring-like structure formed inside the test tube, inside the glass tube. Okay. By this we can say that look here, the distance of HCl. Observe the distance of HCl and distance of the ammonium chloric acid with help of the readings. From this we can say that with the same amount of time, with a particular interval of time, the ammonium liquid which is a form of gases will travel longer distance as compared to the HCl. From this we can say that the speed of the gases will different according to the substance. So from this we can say that ammonium which is in the form of gases will travel longer distance, will diffuses longer distance with the same interval of time compared to the hydrochloric acid. After meeting, it is able to form wide ring-like structure. Clear? So from this experiment we can say that the speed of the gases will depends upon the element. So look at this. Before that, you have to know the difference between solid, liquid and gases. Look here. Let us look at the difference between solid, liquid and gases. Coming to the solid. In the solid, the intermolecular spaces are tightly packed. I'm saying that in solid, the intermolecular spaces, these are the intermolecular spaces are tightly packed. In liquid, the intermolecular spaces are loosely packed as compared to the solids. So here the space between the molecule to molecule, there is a presence of space, right? Presence of space. In gases, the intermolecular spaces are very loosely packed in the gases. Solid, liquid, and it is gases. In solid, the intermolecular spaces are tightly packed and the compressibility is negligible or zero. The compressibility is negligible or zero in solid, whereas the intermolecular spaces are somewhat loosely packed as compared to the solid. The compressibility is very less. In liquids, and the particles intermolecular spaces are loosely packed as shown in the figure. So the compressibility of gases is very higher, and solid has definite, the solid as fixed, solid, liquid and gases. Solid as definite shape, proper shape, fixed volume, compressibility is negligible. In the liquid, it has the shape depends upon the container. It has fixed volume and less compressibility. Coming to gases, it doesn't have no fixed shape, no fixed volume, and compressibility is higher. These are the major differences between the solid, liquid and gases. So fill the table. Shape, given a solid. Solid has a definite fixed shape, okay. And volume, it is also have the fixed volume. Solid will have fixed shape, fixed volume, and compressibility is negligible. Diffusion is lower, slow. And coming to solid, what I said, the compressible solid have fixed shape, fixed volume, compressibility is negligible, and diffusion is lower. Coming to liquid, the shape of the liquid depends upon the container, so no fixed shape. And volume, it has a fixed volume, and compressibility is low compressibility, and diffusion is moderate diffusion. Coming to liquid, shape is depends upon the container, and volume is fixed, compressibility is lower in liquids, and diffusion is moderate diffusion will take place. And coming to gases doesn't have no fixed shape, proper shape, no volume, fixed volume, and compressibility is higher, and diffusion is also higher. These were the major difference between the solid, liquid and gases. So given the activity 7, how small particles of matter. Take a beaker with water, add 1 or 2 crystals of potassium permanganate, that is KMnO4, and dissolve them in water. What color do you observe? Now take out approximately 10 ml of the solution and add it to 90 ml of clear water in another water. What does happen the color of the water in second beaker? Again take 10 ml of solution and add to another beaker of 90 ml of clean water. Carry out this process for 4 to 5 times as shown in the figure 8 and observe the changes intensity of the color of this solution. Look here, this image. Take the potassium solution which is in the form of crystal, take 1 or 2 ml and dissolve in the fresh water, 100 ml of fresh water. After dissolving, what happens? The water will get colored. That light is pinkish, pink color or darkish pink color. After getting colored, take this from this solution, take 10 ml of from this. Look here, I'm repeating 1 second. Take fresh water, take the water. In this water, add 1 or 2 ml of potassium, which is in the form of crystal. After adding crystal, they dissolve. After some time, the crystals of potassium will be able to dissolve in water, and after dissolving, the color of the water changes to pink color. Right? After changing from this solution, take 10 ml of solution and add into the another 90 ml of fresh water. Clear? And observe the color. Repeat this experiment from this beaker. Again take 10 ml of water, 10 ml of solution and add in the 90 ml of fresh water. So repeat this experiment till 4 to 5 beakers and observe the color changes. From this experiment we can observe that the color gradually turns into light pinkish color. Means the concentration of the solution gradually decreases. Whatever the concentration when you are adding to the liquid which is having 90 ml, the concentration was gradually decreases. Due to the decreasing concentration, the color changes. Clear? Next is given that compressibility in water. Okay, take the beaker. In the beaker, pour some amount of water as shown in the figure. Take the beaker, fill the beaker with the water as shown in the figure. After that, add 1 tablespoon of salt. And try to dissolve it. Before dissolving, try to mark the level of the water. before adding the tablespoon of salt, try to mark the level of the water in the beaker. After marking it, try to add 1 tablespoon of salt into the beaker and try to dissolve with help of the stirring. After dissolving, you are able to see that only little bit increment of raising of water level. Why only little bit in raising of water? From this experiment we can say that in liquid, whatever the intermolecular spaces in liquid, there is a presence of some amount of spaces present. In that spaces, whatever dissolved salt is occupied the left spaces, empty spaces. Whatever the dissolved or salt we placed in the liquid, that salt is able to fix in the intermolecular spaces, freely spaces, occupied spaces. Simply that salt is able to enter into freely spaces. From that spaces, for that reason, the level of the water is not increasing rapidly. After adding 1 to 2 tablespoons, the water level will gradually increases because the intermolecular spaces were tightly packed and there is no space to add inside the particles. So from this experiment we can say that in liquid, the intermolecular spaces, the molecules have some intermolecular spaces. Clear? Next is given the activity 9, observing the force of attraction between the particles of matter. Force of attraction, particles of matter. So open the tap and try to place the hand middle of the water that which is flowing down. So before you are able to observe that when you are opening tap, the water drop of the dropper water molecules are able to united together and able to forming as a solid thread-like structure. So because the water molecule, the force between the bond of the water molecule, the force between Activity 9 regarding observing the force of attraction between the particles of matter. So try to open your tap at your home. While you opening tap, you are able to see that the droplets of water molecules are combined together and able to form as a thick long thread-like structure, right? So from that you are able to say that the drop by drop water molecules are able to combine together, attracting together and able to falling down. Whenever the piece of chalk piece I broken down, before breaking down, the pieces, the smaller particles, the dust particles, dust powder molecules are able to combine together. So simply we can say that the forces of the water which in the form of solid, liquid and gases, the particle to particle there is having combining capacity. Due to that combining capacity, the proper chalk piece which is in the form of cylindrical able to forming. So from this we can say that solid and liquid and gases, there is a force of attraction between the gases to gas, particles to particle. Clear? And it is image, it is solid, liquid and gases. Look here, in solid the intermolecular spaces are negligible. The solid, the intermolecular spaces are very tightly, highly packed. For that reason, the compressibility is negligible. In liquid, the intermolecular spaces are loosely packed as compared to the solid, right? So from this, in liquid, the compressibility will be lesser, very lower as compared to the solid. And gases, the intermolecular spaces are very loosely packed. So for that reason, the compressibility will be very higher. So compressibility is negligible in solid and lower in liquid and higher in gases. And the rate of diffusion is higher in gases. Diffusion is higher in gases. In liquid, diffusion is moderate, and in solid the diffusion is low or slow. Clear?